Imagine thinking of someone you haven't spoken to in weeks, maybe months, their face surfacing in your mind for no obvious reason, and within seconds, not minutes, not hours, but seconds your phone lights up with their name. The timing feels impossible, uncanny, as if some invisible thread connected your thoughts to theirs across distance and silence. You've felt it, haven't you? That eerie moment when a friend texts exactly what you were about to say, when your twin calls the instant you reach for the phone, when you sense your mother's worry before she even dials. Millions report this experience across cultures, across continents, across centuries. Coincidence, we tell ourselves. Pure chance. Statistical noise in a world of constant communication. But what if the explanation runs deeper than probability, stranger than psychology, rooted not in superstition, but in the most cutting-edge and bizarre corner of modern physics? Some scientists, working at the fringe of accepted theory, propose a radical idea: that human consciousness itself might exhibit properties seen only in the quantum realm. A domain where particles defy common sense, where cause and effect blur, and where two things separated by the width of the universe can influence each other instantaneously. They call this phenomenon quantum entanglement, and Albert Einstein himself called it spooky action at a distance, because it violated everything he believed about how reality should behave. If entanglement governs particles, could it also govern minds? Could the sensation of telepathy, dismissed for so long as fantasy or wishful thinking, actually hint at a connection science is only beginning to understand? To grasp the strangeness of what's being suggested, you first need to understand what quantum entanglement truly is. In the subatomic world, two particles can become linked in such a way that measuring one immediately determines the state of the other, no matter how far apart they drift. Change the spin of one electron and it's entangled twin light-years away. Reacts in perfect synchrony, not because a signal traveled between them, but because, at a quantum level, they remain a single system. No message crosses the void, no energy bridges the gap, yet the connection persists, instantaneous and absolute. This isn't science fiction. It's been proven in laboratories worldwide, forming the backbone of emerging technologies like quantum computing and quantum encryption. The universe, it turns out, allows for connections that classical physics said were impossible. But here's where the controversy ignites. If particles can be entangled, and if the human brain, composed of roughly 86 billion neurons firing electrochemical signals, operates, even partially on quantum principles, then could consciousness itself be entangled? Some researchers point to microtubules, tiny protein structures inside neurons, as potential sites where quantum effects might survive long enough to influence thought. The Penrose-Hameroff theory, controversial and hotly debated, suggests that consciousness arises not merely from neurons firing in patterns, but from quantum computations occurring within these microtubules. If true, this would mean your thoughts are not just biochemical reactions, but quantum events, potentially capable of linking with other quantum systems, including other minds. Now, skeptics will rightly point out that the brain is warm, wet, and noisy, an environment hostile to the delicate quantum states that require near absolute zero temperatures to persist in a lab. Quantum coherence, the condition necessary for entanglement, should collapse almost instantly under such conditions. Yet recent discoveries have stunned the scientific community. Photosynthesis, happening inside plants at room temperature, relies on quantum coherence to transfer energy with near-perfect efficiency. Birds navigate using quantum effects in their retinas to sense Earth's magnetic field. Biology, once thought too messy for quantum mechanics, is proving to be far more quantum than anyone imagined. If nature harnesses quantum phenomena in leaves and eyes, why not in neurons? There are experiments, small and often ignored by mainstream science, that seem to support the idea of mind-to-mind connection. In the 1990s, Mexican neurophysiologist Jacobo Grinberg-Zilberbaum conducted studies where pairs of people meditated together to synchronize their mental states, then were separated into shielded rooms. When one person's brain was stimulated with flashes of light, producing measurable electrical activity, the other person's brain isolated, unstimulated, showed similar patterns at the exact same moments. The results were published in peer-reviewed journals, replicated in follow-up studies, and then largely forgotten, buried under the weight of skepticism and the difficulty of explaining them within conventional neuroscience. Critics argue the effect was an artifact, a coincidence, an error in methodology. but the data remains unexplained and unsettling. Other research has probed the phenomenon of twin telepathy, where identical twins report sensing each other's pain, emotions, or thoughts, even when continents apart. Controlled studies reveal that twins score slightly but statistically significantly better than chance when trying to guess what their sibling is thinking or feeling. Mothers often describe knowing with bone-deep certainty when their child is in danger, even across vast distances. Skeptics attribute these experiences to hypervigilance, to subconscious pattern recognition, to the brain's tendency to remember hits and forget misses, a cognitive bias called confirmation bias, where you recall the one time you thought of someone and they called, but forget the 100 times you thought of them and nothing happened. And this is the maddening crux of the mystery. Both explanations feel true. Yes, our brains are prediction machines, constantly modeling the social world, inferring what others might do based on past behavior, shared routines, and unconscious cues. Yes, in a hyperconnected world where we think of dozens of people daily and receive dozens of messages, some overlap is inevitable. But the feeling, when it happens, that jolt of recognition, that sense of something beyond coincidence, is so visceral, so common, that dismissing it entirely feels incomplete. Millions of people, across time, have felt this connection. Ancient cultures built entire philosophies around it, speaking of collective consciousness, of oneness, of invisible threads binding all living things. Were they simply wrong, or were they, in their own language, describing something real? Quantum physics itself forces us to confront uncomfortable questions about the nature of reality. The observer effect shows that the act of measurement changes the state of a quantum system. Before you look, a particle exists in a superposition of all possible states, and only when observed does it choose one. Some interpretations suggest that consciousness plays a fundamental role in collapsing these probabilities into definite outcomes, that mind and matter are not separate, but intertwined at the deepest level. If observation affects particles, and if particles make up everything, including brains, then where does the boundary between mind and world truly lie? Here's what we know for certain. Quantum entanglement is real, proven, and operating everywhere in the universe. Consciousness remains one of science's greatest mysteries, with no agreed-upon explanation for how subjective experience arises from matter. The brain exhibits electrical and chemical activity that, under certain interpretations, could permit quantum effects to play a role, however small. And billions of people, throughout history, have experienced moments where the barrier between self and other seemed to dissolve, where thoughts appeared to leap from one mind to another without words, without signals, without any known mechanism. So is telepathy real? The honest answer is we don't fully know. Mainstream science says no, that every reported case can be explained by psychology, probability, and pattern recognition. But a small, persistent group of researchers, working at the edges of physics and neuroscience, say, maybe. Maybe the universe is stranger than we allow. Maybe consciousness, that most intimate and inexplicable part of being human, operates on principles we haven't yet discovered. Maybe the feeling of connection you experience when thinking of someone an instant before they reach out isn't magic, isn't delusion, but a whisper of something quantum, something fundamental, something woven into the very fabric of existence. And if that's true, then what comes next changes everything: how we think about mind, about connection, about the invisible forces shaping our lives. The question isn't whether you believe in telepathy. The question is whether you're willing to explore the possibility that reality is far more interconnected, far more mysterious than the world we think we know. So the question shifts. If telepathy or something resembling it might operate through quantum mechanisms we barely understand, how do you test it? Not in a sterile laboratory with electrodes and shielded rooms, but in your own life, with the people you're closest to. Science, after all, begins with observation, with curiosity about patterns that don't fit expectations. If you've experienced these moments of uncanny connection, you owe it to yourself to examine them honestly, systematically, without the bias of either blind belief or automatic dismissal. The task is simple, though it requires something many people resist: rigorous honesty about failure as much as success. Choose someone you feel deeply connected to: a partner, a sibling, a lifelong friend. Agree on a protocol. At random times throughout the day, one of you will sit quietly, focus intently on the other person, and try to send a thought, an image, an emotion. The other person, going about their day, should note any sudden, unexplained urge to reach out. Any flash of the sender's face, any intuitive pull. Document every attempt, whether it results in contact or not. Here is the crucial part. You must record all the times you think of that person and they do and call. All the times you tried to send a thought and received no response. Confirmation bias, that trickster of the mind, makes us remember the hits and forget the misses. If you truly want to know whether something beyond chance is happening, you need the full data set, not just the memorable moments. Most people who conduct this experiment honestly will find that their hit rate hovers near statistical chance around the frequency you'd expect from random overlap between two people who think of each other often and communicate regularly. But some, a persistent minority, report results that edge above baseline, not dramatically, but consistently enough to feel meaningful. These outliers don't prove telepathy exists, but they keep the question open. A crack in the door that mainstream science prefers to keep firmly shut. And that's the beautiful, maddening thing about this mystery. It lives in that uncertain space where data whispers possibilities without shouting certainties. Now, step back and consider what it would mean if quantum entanglement truly extends to consciousness. Philosophically, this would vindicate what mystics, poets, and spiritual traditions have claimed for millennia, that separation is an illusion, that at the deepest level, all minds are threads in a single tapestry, that the boundaries between self and other are conventions of perception rather than absolute divisions. Buddhism speaks of interbeing, the idea that nothing exists independently, that every being contains and is contained by all others. Sufism describes the unity of existence, where individual souls are waves on a single ocean. Indigenous cultures across the world have long held that humans, animals, plants, even the land itself, share a consciousness that connects all living things. Western science, with its emphasis on material separation, objective measurement, and reductionist analysis, has spent centuries dismissing these ideas as poetic metaphor, beautiful perhaps, but ultimately unscientific. Yet quantum physics has dragged science kicking and screaming toward conclusions that sound remarkably like ancient wisdom. The observer effect suggests that consciousness and reality are not separate but interdependent, that the act of observation shapes what is observed. Entanglement shows that distance, that most fundamental separator in our experience of the world, is not an absolute barrier at the quantum level. Non-locality, the principle that entangled particles respond to each other instantaneously regardless of separation, implies that space itself might not be what we think it is, that the universe is more interconnected, more holistic than the clockwork machine Newton imagined. If consciousness participates in this quantum dance, then the boundary between your mind and mind becomes less like a wall and more like a permeable membrane, where information, intention, or awareness might occasionally leak through. But let's not forget the neuroscience, the grounded biological explanation that doesn't require quantum leaps of logic. The human brain is an astonishing prediction engine, constantly modeling other minds, anticipating their thoughts, simulating their perspectives. Mirror neurons, discovered in the 1990s, fire both when you perform an action and when you watch someone else perform it, creating a neural simulation of their experience inside your own brain. When you see someone in pain, your pain circuits activate. When you watch someone smile, your smile muscles subtly twitch. You are, neurologically speaking, constantly inhabiting other people's mental states, running their emotions and intentions as software on your neural hardware. Close relationships amplify this effect exponentially. People who spend years together develop shared rhythms, synchronized routines, predictable patterns of thought and behavior. You learn the micro-expressions that flicker across a loved one's face before they speak, the shift in posture that signals stress, the tone of voice that means they need comfort. Most of this processing happens below conscious awareness, in the vast, submerged bulk of cognition that operates outside the narrow spotlight of attention. So when you feel a sudden urge to call your mother and discover she was just thinking of you, it might not be quantum entanglement, but rather your brain's exquisitely tuned model of her predicting based on time of day, recent events, emotional patterns, and 1,000 subtle variables you don't consciously track. What feels like telepathy might actually be the brain's prediction systems working so well they seem magical. Here's where honesty demands we confront the limits of current knowledge. Mainstream neuroscience insists that consciousness is entirely a product of classical brain activity, neurons firing neurotransmitters. crossing synapses networks activating in patterns, and that quantum effects, even if they occur in microtubules or ion channels, wash out too quickly to influence thought. The warm, wet, and noisy argument stands strong. Quantum coherence requires isolation from environmental interference, and the brain is anything but isolated. Every heartbeat, every breath, every thermal fluctuation should destroy quantum states before they could possibly contribute to cognition. Critics of the quantum consciousness hypothesis point out that no experiment has definitively demonstrated quantum effects persisting long enough or at large enough scales to impact neural processing in ways that would allow for telepathy. And yet, the universe keeps surprising us. Quantum biology has revealed that evolution, that ultimate tinkerer, has found ways to harness quantum phenomena in warm living systems. The European robin's ability to navigate using quantum entanglement in its eyes wasn't predicted by theory. It was discovered by observation and only later explained. The near-perfect efficiency of photosynthesis, once thought impossible to achieve classically, turns out to rely on quantum coherence to explore multiple energy pathways simultaneously and choose the most efficient one. If birds and plants can be quantum, why not neurons? The argument isn't settled. It's ongoing, with new papers published, new experiments proposed, new theories refined. The scientific method, at its best, remains open to evidence, even evidence that challenges foundational assumptions. Let's entertain a thought experiment. Imagine for a moment that telepathy is real, that minds can entangle, that your deepest intuitions about connection are not illusions but perceptions of something genuine. What changes? First, the implications for privacy and autonomy become profound. If thoughts can leak from one mind to another, where is the boundary of self? Could someone, with training or technology, read your thoughts without consent? Would intimacy deepen, or would the loss of inner sanctuary be unbearable? Relationships would transform. Lies would become harder, empathy easier, loneliness perhaps less crushing, but solitude more difficult to achieve. Ethically, if consciousness can extend beyond the skull, our responsibilities to others might expand as well. Harming another person wouldn't just be an external act, but an attack on a being you quantum mechanically linked to, a violation of a shared field of awareness. Philosophies of compassion would gain a physical basis. Treating others well would be, quite literally, treating yourself well, because the boundaries between you and them would be less absolute than they appear. Technology, too, would evolve. If quantum entanglement between minds exists, could we build devices to enhance it? To communicate silently across distances? To share experiences directly from brain to brain? Science fiction imagines such futures. If the science turns out to support it, fiction would become engineering challenge. But even if telepathy, in the end, proves to be nothing more than cognitive bias and prediction, even if quantum entanglement stays confined to particles and photons, never bridging the gap between neurons, the journey toward understanding it has value. The question itself forces us to examine consciousness, connection, and reality with fresh eyes, to admit how much we don't know, to hold space for mystery in an age that often rushes too quickly to certainty. The feeling of connection you experience with others, whether it's quantum or classical, biological or spiritual, is real as lived experience, and that reality matters. It shapes how you relate, how you love, how you navigate the strange, brief adventure of being alive. At the end of the day, the universe doesn't owe us explanations that fit neatly into the categories we've invented. Reality has always been weirder, richer, and more surprising than our best theories predict. Quantum mechanics proved that. Relativity proved that. Every major revolution in physics has been a humbling reminder that our intuitions, shaped by evolution to navigate a world of medium-sized objects moving at moderate speeds, are poor guides to the fundamental nature of existence. Maybe consciousness is the next frontier, the next domain where reality will reveal itself to be stranger and more interconnected than we dared imagine. So, do you believe in telepathy? The better question might be, are you willing to stay curious, to test your experiences, to remain open to the possibility that the universe has not yet finished surprising you? Because whether the connection you feel with others is quantum entanglement, neural prediction, or something else entirely, it's a thread worth following. It leads to questions about who you are, what minds are, and how the universe holds itself together. And those questions, whether or not they yield definitive answers, are among the most profound and human inquiries we can pursue. The mystery endures, and perhaps that's exactly as it should be. Some doors are meant to stay open, letting in light and wonder, inviting us to step forward into uncertainty with awe rather than fear. Your experiences of connection, those moments that defy easy explanation, are invitations to explore, to question, to feel the edges of what we know and what we might one day understand. In the end, whether telepathy is quantum entanglement or the brain's beautiful illusion, the truth remains: you are not as separate as you feel. You are connected, deeply and inextricably, to every person you touch, every mind you meet, every consciousness that brushes against your own. And that connection, in whatever form it takes, is worth honoring, exploring, and celebrating for as long as you draw breath. But even if telepathy, in the end, proves to be nothing more than cognitive bias and prediction, even if quantum entanglement stays confined to particles and photons, never bridging the gap between neurons, the journey toward understanding it has value. The question itself forces us to examine consciousness, connection, and reality with fresh eyes, to admit how much we don't know, to hold space for mystery in an age that often rushes too quickly to certainty. The feeling of connection you experience with others, whether it's quantum or classical, biological or spiritual, is real as lived experience, and that reality matters. It shapes how you relate, how you love, how you navigate the strange, brief adventure of being alive. At the end of the day, the universe doesn't owe us explanations that fit neatly into the categories we've invented. Reality has always been weirder, richer, and more surprising than our best theories predict. Quantum mechanics proved that. Relativity proved that. Every major revolution in physics has been a humbling reminder that our intuitions, shaped by evolution to navigate a world of medium-sized objects moving at moderate speeds, are poor guides to the fundamental nature of existence. Maybe consciousness is the next frontier, the next domain where reality will reveal itself to be stranger and more interconnected than we dared imagine. So, do you believe in telepathy? The better question might be, are you willing to stay curious, to test your experiences, to remain open to the possibility that the universe has not yet finished surprising you? Because whether the connection you feel with others is quantum entanglement, neural prediction, or something else entirely, it's a thread worth following. It leads to questions about who you are, what minds are, and how the universe holds itself together. And those questions, whether or not they yield definitive answers, are among the most profound and human inquiries we can pursue. The mystery endures, and perhaps that's exactly as it should be. Some doors are meant to stay open, letting in light and wonder, inviting us to step forward into uncertainty with awe rather than fear. Your experiences of connection, those moments that defy easy explanation, are invitations to explore, to question, to feel the edges of what we know and what we might one day understand. In the end, whether telepathy is quantum entanglement or the brain's beautiful illusion, the truth remains: you are not as separate as you feel. You are connected, deeply and inextricably, to every person you touch, every mind you meet, every consciousness that brushes against your own. And that connection, in whatever form it takes, is worth honoring, exploring, and celebrating for as long as you draw breath.